Hello. In this little tutorial, I'll explain you the basics of using the Excel solver for solving linear programs in Excel. The first thing you have to make sure that you actually have the solver activated in your system. So this should show under the Data tab to the right. Now, if you do not see it, then this is a free add-in you have to turn on. Uh, if you're using a Mac, then you can just go under Tools, Excel add-ins, and make sure that you tick the Solver add-in. If you're using Windows, you can find the same in the File menu under Options. You can list all add-ins. If you're using an LSE network computer, then the Solver should always be turned on. Our first example of a linear program we solve with this solver will be the very first example of a linear program we saw during the course. This is this laptop production example. So let me just quickly remind you of this example. I've already entered all the data necessary in the Excel sheet. So we need to devise a production plan on how many we wish to produce of each of five families of laptops or variables. X1, X2, X3, X4, and X5 will be the number of laptops in each family given in units of 1,000. So here I have these cells highlighted in blue, which supposed to correspond to these variables. Right now they are completely empty, so we will see how the solver will be able to recognize these. Now, the cost function is given in millions of pounds, and if you recall from the formulation, our cost will be 2 times x1 plus 1.4 times x2, and so on. So this is the total revenue which we will enter in the cell G4. Again, at this point it's still empty. We will need to enter a formula here. Now, our production was limited by a number of constraints. First, there were resource constraints on the number of CPUs, solid-state drives, and memory boards. The table shows the necessary numbers for each type. Like for type 1, you need 1 CPU, 1 solid-state drive, and 6 memory boards. The total availability, again in thousands, is given in this column age 8, 3, and 14. Now we also have demand constraints. The first two of these give our upper bound constraints, namely that for L1 and L2 altogether there is 5 units of demand, whereas for L3, L4, and L5 altogether there are at most 4 units. Now the final two constraints represent lower bounds, which are pre-orders for types 2 and 5 for 700 units each. So this is all the numerical input. We also will require that our variables must be non-negative, but we'll see how that can be handled. So now let us express first the total revenue with a formula. Now this should be obtained by multiplying the values of cells B3, which is supposed to represent the number of laptops of type 1, with the value in B4, which is 2, the unit cost. Plus, we need to add C3 times C4 plus D3 times D4, and so on. Now, we can enter this using the Excel function SUMPRODUCT, which computes the scalar product of two vectors, or as it's called here, two arrays. So first I select the array B3 to to F3, which represents the variables, and then as my second array I select B4 to F4. So again, what SUMPRODUCT does, it takes the scalar product of these vectors, multiplies the first entry with the first, second entry with the second, and so on. Oops, we got 0. Have we done anything wrong? Well, not really. We have empty entries in all these cells. So an empty cell is considered as value 0, so we really multiplied everything by 0. However, if you start entering some numbers here, like 5 in B3, then you immediately see that this is multiplied by 2, so we get a revenue 10. If we enter like 2 here, then we get an additional revenue 2 up to 12 and so on. The other 3 are still 0. So for the constraints, it will be similar. The right-hand sides of the constraints are already given in column H. Now for the left-hand side, we need to again take the scalar product of the third and the seventh row. Namely, we have to take the respective coefficients and multiply them with the variable cells. So again, I use some product here. Let me just again add this B3 to F3 and then add B7 to F7. Now let me make a small change. Let me add the dollar sign in front of the two threes for the variable cells. Now, what's the effect of this? Well, you wouldn't see an immediate difference with or without the dollar signs. However, once you start copying this entry to all subsequent rows, well, let's see what happens. So for the second row, for the solid state drive, we see the identical B3F3 multiplied with B8F8. So the index of the second array changed. It was increased by 1, whereas the one with the dollar signs was fixed, and it doesn't change. So now we can see the scalar products for these random numbers we entered here, 5 for L1 and 2 for L3. Already we see that in terms of memory boards, this is an infeasible production schedule. Let us also delete the 0 in the 10th row, which doesn't represent any constraint whatsoever. Alright, so we have all the necessary formulas. However, we haven't encoded our linear program yet. In fact, from this representation, it's not even clear which of the constraints are smaller or equal and which are greater or equal constraints. All this is something we have to specify in the solver. So let us finally press the solver button. Now we get a new window where we have to specify the objective, the variables, as well as the constraints. First cell is to set the objective, so let us just click on the cell G4, which corresponds to our total revenue. We can select maximization or minimization. We have a maximization problem, so we leave it as is. So now the next requirement is to specify the variable cells. So these are the ones from B3 to F3. So let me just select these cells, and there they are. So now our next quest is to add the constraints. So let me add these constraints one by one, although we could also add them in a block. So for each constraint, we have to specify the left-hand side and the right-hand side. The left-hand sides are represented by the sum products we entered. So for the first, the CPU constraint, the left-hand side is G7, which should be less or equal to H7, which is 8. So this is our first constraint. We press add. Now this appears on our list, but we just moved on to adding the next constraint. So this will be on the solid state drives. G8 should be, let us click on the constraint cell, should be at most H8. So again, I added this one. And finally, G9 should be at most H9. Okay, so we have added these three constraints. If we press cancel, we already see these three constraints listed. But we are not done yet. We also have the demand constraint, so let's continue with adding. So let me add G11 is at most age 11, and G12 is at most age 12. Now let us be careful with the final two constraints because they should be greater or equal constraints. So that's why I changed the direction, and it should be at least G AH13, and our final constraint is G14 should be at least age 14. Okay, so we had added all these constraints. Now there are some more constraints missing, which could be easy to forget. These are the non-negativity constraint. So luckily, these are added by default, but this is something we have to be aware of. If we tick this box, then all variables are assumed to be non-negative. If we don't tick it, then none of our variables will be require non-negative. So it's all or nothing. If you have a mixture of non-negative variables and free variables, then you don't tick the box and you add individual non-negativity constraints. All right, so select solving methods. Now, this Excel solver has broader capabilities than just linear programming, but let us not worry about that. Let's just go for the simplex LP. So this is the simplex algorithm for linear programming, the method we are also going to learn during the term. So we have everything set. We have an objective function to maximize. We have variables as constraints, non-negativity constraints, and we have a solver, select solving method selected. So we are ready to press solve. So here we already see the solution. So we pick keep solver solutions. Now there are a number of reports we can also select. Now I selected them. You don't need to worry about these for now. But I just wanted to show that these will appear in other cells. But if we just look at other sheets, but if we just look at our original sheet, then actually we can directly read off the solution. So the solution was to produce 1.5 units of L2, which is represents 1,500 from this type because our units are in thousands. And then from L4, it's 3.3 and L5 is 0.7. The total revenue is 5.09 million pounds. What we can also see from here is which of our constraints are hold at equality. So for example, the CPU constraint, it's 5.5, which is definitely smaller than 8. Same for SD, solid state drives. Now for the memory boards, we see that those are really used to the total maximum extent. Similarly, among the demand constraints, the demand for L3, L4, L5 reaches the possible maximum of 4, whereas the demand for L1 and L2 is well below the maximum possible. Also for L5, we just produced a bare minimum of 700, which is required, whereas for L2 we produce a higher amount. Recall that these final two constraints were greater equal constraints. So that was it for now. We showed how simple LP can be input and solved using the Excel solver. Thank you very much for your attention. Bye.